Hi, my name is King, and today I'll be talking about the backend component of our drug monitoring application for cloud computing. So, let me just turn this down for now. So, my task primarily is to create a database to interface the database with CTIGs and SparkStream from Shinju and Raymond's part, and to push data to the front end by means of doing something. Those are my specifications and my role in this project. So initially, I met up with Raymond Shinju and discussed what we needed in the database. And we figured that we needed an ID field and a tweet and symptom right here. But we figured out that eventually that all we really needed was ID, drug, symptom, and tweet, because we are just literally just going to query the user would type in a drug, and we would look up in our table for that drug, isolate it, and group all the symptoms together and represent that in a word cloud, in a pie chart, in a bar chart, whatever. So that's what we did in terms of our models. Also, another task that we had to do was to figure out how to make a product for our customer. What we did was I had a lot of experience with Django and Django web development, so we decided to use Django as a way of having something. We use DigitalOcean. It's a provider that spins up VM instances for developers to use, and it spun up a Django instance for us to use, and there we go. So we're using Django to host our application. So you might be wondering how everything works, how our database goes from our backend to the front end. So right now we have this is our server, that's our password. We're going to change it obviously after this. We have code right here that pretty much does what I just mentioned like 30 seconds ago, that groups all the drugs, common drugs together and finds the count. And we have some fun string manipulation to get it in such a way that HTML right over here would understand what it means. So for our draw chart, for our draw chart function, we have a chart that gets passed into it, and that's literally from here. So that's what I'm doing as the person responsible for the back-end to front-end integration. And I know for a fact that Raymond will be talking about how he is constantly pushing data into our database. So there's that too. Also, in the beginning of our project, we were given a GC instance. So I'm just going to spend the last 30 seconds talking about why we didn't use GCE, which is also leads us to what I personally learned about the project. So GCE works for Django. That I know for sure. Cassandra also works with our project. That I know for sure. But we're choosing DigitalOcean and Postgres because we know for sure this works. GCE doesn't really work that well with Django. I didn't really find enough documentation to fully implement Django in GCE, but I do know for sure that Cassandra works on GCE, and I will show you right now. So this right now is our GCE instance. Let me show you my script. This is my script. Basically, it has all the clusters. It reads it in and it inserts it into our database. And then here is our CQSH. Here is Cassandra. And I can do something like see. And as you can see, we have all the tweets being inserted into our Cassandra database in GCE. So everything works. It's just we've been having a lot of troubles getting Django working, and we found that it works really well in DigitalOcean, so we want to proceed from there. We have DigitalOcean allows us to scale up to 16 gigs. We can install SBT onto DigitalOcean, and we can run SBT, run the Spark stream, run the CTIX there, and we're using that right now as a proof of concept before we can move on with GCE. Obviously, we have a lot of components right now completely implemented on GCE, but it's just we didn't really have the time to completely congeal everything, as opposed to how everything just works in DigitalOcean. So there's that. That's what I learned in terms of my